All right. Okay, so please take out your notes. We're looking at 3-3. This will not be on the quiz tomorrow, okay? Get this. All right. So I'm sure you were all just anxiously awaiting for, trig to join the party of derivatives, so it's about to join, okay? Now, looking at the graph on the left, who could tell me which trig function is graphed there? Okay, good. So it's sine x, right? Okay. So let's go ahead and, so this is sine x. And let's sketch the derivative of sine x. So to sketch the derivative, right, we were doing this a couple weeks ago, actually, yeah, a couple weeks ago. First thing I'd want to do is look at where would its tangent lines be 0. And it's looking like it would have tangent lines with the derivative 0 at pi over 2. So I'm going to have a point right here, and at 3 pi over 2. Okay. Now let's go back and look at what is happening from here to here. It's positive, correct? Okay, it's positive, but it's approaching 0, correct? Okay. Now, where is it going to have the steepest slope? Looks like right here. And in fact, if I were to draw the tangent line, okay, right at this point, it's looking like it has a slope of, probably more like this actually. Looks like it's having a slope of 1, okay? And that looks to be the steepest it's going to be. So right here it has a slope of 1 and it's approaching 0. So at 0 it's got a slope of 1 and it's slowly going to 0. Okay, notice that the derivative is positive here. So right here I'm taking the derivative of sine x. Okay, and then we see symmetry in this, correct? So if there's symmetry here, we're going to see symmetry in its rate of change. So right here, so now from here to here, it's negative, correct? Right here it looks like it would be the steepest. What do we think the slope is at pi? -1, right? So I'm going down to -1. So it's going like this. But then what happens? It's still negative, but it's going back to 0, correct? So this is coming back up. But notice what's important. It's still negative, okay, because it's underneath the x-axis, but it's going towards 0. And then what happens, right? Right here again, it looks like, right, it's 1 again. So it looks like it's going back up to 1, and it's kind of just going to continue to do this. So what does that look like? What trig function does that look like? Cosine. Yes, okay. So the derivative of sine is cosine, all right? And we could actually prove this by using that definition of the limit and a lot of advanced math that you guys don't quite have yet, okay, but it has been proven. So if you look down below, we're not going to go through all of these, but we have these derivatives, okay? So the derivative of sine is cosine, which we just looked at, okay? The derivative of cosine is negative sine x, okay? Derivative of tan ends up being secant squared x. Okay, and again, how are they coming up with these? They're using that definition of the derivative, taking the limit as x approaches a, or the limit, right, as h approaches 0. Okay, so we're not going to go through all of that because it's a ton, like I just said, a ton of math, okay? So we're going to take it with faith. So we have the derivative of cosecant is negative cosecant x, and then when they're right next to each other, this means multiplying, okay? And we have secant. Derivative of secant is secant x times tan x. Derivative of cotangent x is negative cosecant squared x. Okay, so unfortunately, these need to get memorized. Okay, I think I've mentioned in this class, we're only at the tip of the iceberg. Okay, meaning there's many more things to come. So again, note cards. I've seen some people start them. This would be something to add to your note cards, all right? Because you got to have them memorized. Now, there are some little patterns that are helpful, okay? First of all, notice that when you have a cosine, you have a cotangent, you got a cosecant, all their derivatives are negative, okay? Notice that all their derivatives are negative. So the derivative of a cosine, it's going to be negative. Derivative of a cosecant, it's negative. Derivative of cotangent, it's negative. Okay? You'll also notice that there's a little bit of a pattern. Okay? The derivative of tan ends up being secant squared x. Okay? Derivative of cotangent ends up being the negative cosecant, right, which are reciprocals. Right? And you can also kind of, there's some other little patterns. But unfortunately, they gotta just get memorized. Okay? So, memorize. However you feel will help you, you gotta get it memorized. All right, so let's look at an example. All right. So before I just, plunge into quotient rule, which I hope people are thinking, I want to first think, can I simplify this? So can I divide secant x by 1 plus tan x? No, no, we can't, okay? We can't because this isn't just one term down here, right? Okay? Now, you might be thinking about identities. We're going to get to that on the next page, okay? But right now, I'm not seeing any glaring identities, all right, which we'll talk about in a minute if you've forgotten. So we are going to use quotient rule. All right, so let's do it. So again, I'm going to start down low. I'm going to square the denominator. Sorry, my plus kind of looks like a T. There. And then I'm going to recopy that right here. All right. Next to it's going to be the derivative of the top function. So the derivative of secant x is... Right, and that means multiply, okay? So I'm going to write this. It's going to be secant x. And if you want to, for now, I'm going to put a times here just so people, after a while, I won't put that though. So I have 1 plus tan x times secant x times tan x. Now, could I actually have put grouping symbols around both of those? I could have, okay? So there's quite a few ways you could write that. And then I'm going to have a minus, and now I'm going to put secant x times the derivative of 1 plus tan x. Okay, so derivative of 1, 0. Derivative of tan x. Right. Okay. Now I'm going to stop just for a second. You don't have to write this down in your notes, okay? But I want to remind people, this is not the same as this. All right? If you do want to put this in your notes, you can. But these are not the same thing. Okay? When I write it like this is really meaning secant x is being squared. In fact, I myself, for a long time in math, when I saw this, because it kind of confused me a little bit, I would just rewrite it like this. I would go, okay, it's secant x being squared. I would write it like that, okay? This is the same as this, all right? This over here is meaning secant, and then it means inside it's x times x, okay? So operationally, this one is saying, for example, if I put in 1, I would take, okay, what's secant at 1? Well, secant is 1 over cosine, correct? Let me say 0, okay? Let's say 0. So secant at 0, well, secant's 1 over cosine at 0. Cosine at 0 is 1, okay? So this is going to be 1 squared. Okay, over here, it's saying, okay, this would be 0 times 0, which is 0, and then I would take the secant. Now, in that situation, it happens to be the same, because 0 times 0 is 0. But if I had chose, let's say, pi over 4, pi over 4 times pi over 4 would be pi squared over 16. Okay, over here, it would be secant at pi over 4. Okay, they're not going to get the same answer. Okay, so really important to understand the difference with those. Okay, all right. And I know you guys talked about this in pre-calc, but just a little reminder. All right, let's go back to the problem. All right. Okay, so looking at this problem, I'm not going to start to FOIL things out because I see that this is one term, this is another term. And I notice that they have a common factor. It looks like they both have a secant x. Okay, so I can factor out a secant x. Okay, I can't factor out a tan x. Well, first of all, this one doesn't have a tan x. Okay, so I can't do that. Also, can I cross cancel these right now? It's very tempting. Okay, who can say why we cannot? Because we actually cannot cross cancel those. Well, do both of these terms have it in common? No. Okay, so I cannot cross cancel here. Okay, if it was just this, could I cross cancel one? Yes. Okay, so that's the difference. But I am going to factor out a secant x. Okay, so as soon as I take out a secant x, I have this factor times tan x, correct? Write that down. Minus, okay, I took out this one, so I still have a secant squared x. You know what? I just realized I meant to do this problem on the other side. That's okay. Yeah, that's all right. Okay, sorry, I didn't mean to quite do this one quite yet, but that's all right. Let's carry on. All right, so now I'm at this point. And now I actually want to think about some identities. Okay, so let's flip the page where this problem was supposed to be done at. But flip to the other page. And we got here a nice list of some trig identities that are good to know. All right. So let's just have, Elizabeth, could you read off the first one? Okay, good. The next one, Sylvia? Okay, good. Alfredo, the next one. Next one, Gabby. Okay, now I think those ones you all should have known. Okay, so these ones I'm thinking you knew those, okay? Now the next one, Pythagorean identities. Cameron, would you read the next one?
Cosine squared x plus sine squared x equals 1.
Okay, how many people remember that one? Okay, that's a big one, okay? This is like, gets little stars. Okay, this is one you wanna, the ones up above you need to know as well. This one you need to know, all right? Okay, and it literally comes from using a right triangle in the unit circle. I'm not going to go through where it comes from. You can come and talk to me at lunchtime if you forgot. But this is definitely a big one, okay? And it's got to be a plus, because it literally comes from a squared plus b squared equals c squared, okay? And on the unit circle, the hypotenuse is 1. Okay, that's why that's a 1 there, all right? Now, all of these other ones come from this, okay? So I'm going to put a little arrow kind of showing, just saying, all of these other identities come from the cosine squared x plus sine squared x equals 1, okay? So just to demonstrate, this one, what did we do to go from here to here? Right, we just subtracted the cosine squared x, okay? When we went to here, we just subtracted the sine squared x. Now, what did we do to get this? We actually went back, if we divided all of these by a cosine squared x, okay, this divided by cosine squared x would be 1. This divided by cosine squared x would be sine x over cosine x, which is tan, but it's being squared, tan squared. This would be 1 over cosine squared x, which is the reciprocal, correct? Secant squared x. Okay, so that's all we did to get that identity. And I know last year you did lots of fun, right? You guys did all of these for a while. I loved that part of trigonometry. I did, okay? But I know other people didn't. And then here, we divided by sine squared x. Right? So these identities are nice because sometimes when you're seeing a sine squared x or a cosine squared x or a tan squared x or a secant squared x, you might want to substitute. And in fact, secant squared x is the same as 1 plus tan squared x. So let's go back to that problem that we were just looking at. That's supposed to be right here. Okay, but we'll go back to it. That's why there's not quite enough space on this, but okay, so let's go back. I'm going to write a little bit smaller. And I'm going to have secant x. Now, right here, could I distribute? Okay, so I'm going to do that. I'm going to have tan x plus tan squared x minus, and then right here, instead of putting secant squared, and the reason why I'm going to an identity is because I see I got tans here, I'm going to go ahead and put that 1 plus tan squared x. And I want to put that in grouping symbols. And again, that's all over okay. So what could I do now? Can I distribute the negative? Okay, and it looks like, would that positive tan squared x and negative tan squared x, would they cancel? Yes. Okay, so I'm going to go over to here. So it looks like I'm going to have a secant x times, I think I'm going to end up with a tan x minus 1. Over the 1 plus tan x squared. Okay, at this point, it would be really nice if I could cross-cancel these, but are they the same? No, are they opposites? No. Okay. If they were opposites, it would be nice, but to be opposites, I'd have to have a negative in front of this, right? So I could factor it out, and there's not. So unfortunately, or fortunately, we're done. Okay? That is our derivative. Okay? All right. All right, so now let's go to that other page. And we'll put the simpler problem that I was going to do first, okay, just to have another example there for you. Let me get to that page. Here we go. And let's just put okay. So one last one. What are we gonna, who can start this problem for us? Elizabeth, say it a little bit louder. Okay, good. I heard product rule. Yes, okay, because we have cosine x times sine x. So I'm going to write product rule. And let's go ahead and start that. So Cameron, derivative of cosine. Go back and look on the other page if you're not sure. Derivative of cosine. Very good. Okay. So actually, though, let's double check. Do I want to take the derivative of cosine yet? No. Okay. So let's go ahead and put cosine x times. I'm going to go back and put times the derivative of sine x. Good, which would be cosine x. Plus, okay, now sine x is going to stay the same. Now I'm taking the derivative of cosine. Say it again, Cameron. Right, so good. Times, I'm going to put that in grouping symbols. All right. So a cosine x times cosine x, I could write as cosine squared x. You could also choose to write it as cosine x with grouping symbols and a square on the outside. That works. Pull that negative in front. Sine squared x. Do I want to right now say, oh, this is 1? No, because it's a subtraction. Okay. Now you might remember there is some other identities that go with this, I think, but we're not going to use them. And as you can see, since I don't even have them on the top of my head, they're not going to come up. Okay. All right, so we are done. All right, so with that, we're going to practice this today and tomorrow. And I will write the homework up here. So we're in unit 3.3. Okay, so this is due tomorrow with yesterday's homework. Okay, so hopefully you got through most of yesterday's, hopefully. Okay, and we will get started on this now. All right. I'll see you later, Gabrielle.